Okay, so here we go. Let me turn on the lights.
Yeah, I got 4. I've got like 4 hours.
There we go.
Yeah.
Okay. So let's do some exciting math problems together. So we finished up with chapter 4. Yes. No, I did not. You are Grayson. Okay, perfect. There we go. So the only ones I haven't gotten yet is Rodrigo here yet? How about Arturo or Michael or Olivia or Megan? But Megan, something said she's got. Okay, sick. Okay, I'll write an excuse for her then. Okay, so actually, is there anybody else who can confirm that? Anybody else?
That Megan is?
Yeah.
So we're on the same team and she was
Okay,
at
okay.
breakfast this morning. My
Okay,
coach
okay.
told us that she had told him
Okay,
that she
okay.
was sick.
Okay, okay. I guess that's good enough. Okay, so Olivia is not here, Michael and Arturo, right? Okay, perfect. So next we have to do some factoring. So this is not, I have not actually finalized this assignment yet, so it's not, I haven't posted it in Pearson yet. But because I also want you to finish your test on chapter 4 first. But this is the way we're going to learn next though. So, and this could possibly change. So these numbers, like if I write down number 10, for example, on your actual assignment, it might actually be number 11 or number 8 or something instead. So just be aware that these numbers might change slightly from what they are written down right now. So the first example for chapter 5, by the way, should I be nice on chapter 5 or not?
Yeah.
Let me just check and see if I really want to be nice or not. Oh no. Oh no. Okay, well, I'm not sure if it's going to be chapter 5 or chapter 6 that I'm nice on. I guess it could be chapter 5. But I can only do it on one though. But one chapter each semester, it's usually chapter 5, I think. I let people get 50% extra credit for. But so on every question you get perfectly right, you'll get 50% extra credit for. And I guess I'll do it on chapter 5. So because it's actually, that's a good choice because chapter 5 is about factoring, and factoring is probably the most important part of algebra. Yes. Because factoring is how you break down a bigger level problem into 2 smaller level problems. So in chapter 5, you're going to get 50% extra credit for everything you get right. So if you don't do anything, you won't get any extra credit. So basically, the more things you get right, the more extra credit you'll get. So you could theoretically get 150% out of 100 on this chapter. And I'll even do it on the test and on the homework as well. But this is the only time it'll happen. That won't ever happen on any other chapters. So make sure you pay close attention so you can get everything right. And we're supposed to do what's called factor. So how do you factor this? Factoring means breaking apart something into 2 things that multiply together to make the original thing. So what does that mean exactly? Well, I'll give you an illustration. Y squared can be broken apart and factored into being a y alone times another y alone. So y times y factors out y squared. And let me get a drink, by the way, because I have been talking with no drink for like a couple hours. What would be worse, having no food or no water for a day?
No water.
No water. Yeah, you're right. Me and my sister actually did a contest one time. We went from 8:00 a.m. one morning to 8:00 a.m. the next morning with no food and no water. And by like 5:00 p.m. the first day, we couldn't think about food anymore. We could only think about water.
Last 3 days without water, you can last 3 weeks without food.
I know, you're right. You're right.
Water, like so bad for a day.
Yeah, that would have been easier. So, and then here's a trick, and a lot of you may not realize this, but I'm going to teach this to you. I didn't even know this, even after I was all the way done with college, and I was teaching math even, and I was like getting my PhD. I didn't even know this until somebody from another country who's a student just like you was actually working on some math with me, and I was helping him with some math, and he actually told me a secret that I'd never known. You can actually bring down the sign between the first 2 terms like that, And then the trick is if you multiply the sign between the first two terms times the sign between the last two terms, you'll get the sign in the next parentheses. So what's a negative times a positive? It's a negative, right? So the second sign is a negative. Now, when you do this, you have to put the bigger overall value in the first parentheses later on and the smaller one in the second. But as long as you do it like that, this shortcut will always work. So I think it's a pretty helpful shortcut because then all you have to think about now is two tiny little numbers. You just have to think of what number goes in those two spots. Everything else in the problem has already been figured out. How do you calculate the numbers that are in those two spots? So I'm going to teach you something it's actually redundant in this problem, but it's going to tell you the deep dark secret that will work for other problems later on. So notice that the line I drew between the first sign and the second sign is kind of like a small rainbow. Have any of you ever seen a double rainbow before? So what you have to do is make a double rainbow like this. There's really an invisible one at the beginning of the problem, right? Make a second rainbow connecting the one at the beginning to the number at the end and multiply those numbers together, first and last. So 1 times 77 is equal to 77. That's why I said it's redundant. So a lot of people, they just learn to ignore the first number. But the thing is, you can't always ignore it though. So I'm teaching you ahead of time to include it because we want to make sure we take into account all the numbers. So you multiply the first number times the last number and you get 77, which is the same as the last one. By the way, when you do this shortcut that the foreign student taught me how to do, because there are a lot of foreign people actually are a lot smarter than we are, but that's the truth because they have like more hours of school and like more strenuous attention on their studies and everything like that. But the 77 though, forgot what I was saying. So we have the two signs, we brought those two signs down. First sign comes down, the second sign is a negative times a positive, which makes it negative. We have to find two numbers that come from 70. Oh, I know what I was going to say. You don't have to worry about the sign of the 77 anymore because you already have the signs figured out. So in fact, even if the 77 is negative in the problem, as long as you have the signs written down outside the boxes, see those two boxes, as long as you have the signs in front of them already written down, you can ignore the negative on the 77. So what numbers multiplied equals 77? 1 and 77. What else? 11 and 7. And actually, in this case, which number should go in which box? And how do you know which one should be? So we already took into account the first number and the last number. Now is when we need to think about the middle number. The only numbers that can go in those boxes are the numbers that will add up, including the signs in front. This includes the sign in front of the boxes. They have to add up to equal the middle number. So they have to add to equal the original number in the middle, which is negative 18. So which pair of numbers can go in those boxes? 7 and 11, you're right. And does negative, now notice if you include the negative now, which has already been figured out ahead of time, does negative 7 plus negative 11 equal negative 18 or not? There we go. Perfect, it does. So smart. By the way, does that look like a little face right there with like sort of sad face in that box? Yeah, that's what I was noticing. Okay, so y minus 7, y minus 11, and then we're done. So we're not even solving the problem, we're just breaking it into two pieces. So y minus 7 times y minus 11. Has anybody ever done this before? Perfect. Okay, so you understand that like if you multiplied it back together, you would get the original problem again, right? So let's try to do something a little more difficult. Let's try to do the third problem. So the third example that I have, it says y to the 2 minus 10y minus 24. And let's try that trick again with the signs. So the first step is to drop the square from the y and write a y separately once in each parentheses. So that breaks it apart into factors. Y in one, y in the other, because y times y equals y squared. What sign should I put in the first pair of parentheses in the middle after the letter Y? I can put in that same negative sign that was there already. But what sign should I put in the second one? This is confusing because a lot of people would look at this and they'd think, well, you need to put the second negative sign in the second factor, but that's not right. How do you know it goes in the second factor? It's the result of multiplying these two signs together. What's a negative times a negative? Positive. So that actually is going to be a positive sign. Then you have this little blank space. Did you know Taylor Swift wrote a song about a blank space one time? Oh, you have like a little blank space right there to write something down in. How do we know what to write down in that blank space? It has to add up to equal the middle number if you include the signs in front. But how do you know what to start with though? So we're going to put in that invisible 1 at the beginning and we're going to draw a double rainbow above the top and do 1 times 24. Now this time I'm actually going to ignore the negative because we normally cannot ignore the negative because the sign actually does matter. But we've already taken into account the signs already. We've already figured them out. So we don't need to worry about the signs anymore because the signs will already be there ahead of time. So just multiply the 1 and the 24 together and ignore the negative. If you had another math teacher, they'd probably say that they probably would think that you're skipping a step because I bet you that most math teachers probably don't even know about this shortcut with the signs. So the good ones probably do. Maybe they do. Maybe I was the only one that didn't know it. But anyway, this looks like I'm doing the wrong thing, but we're really not doing the wrong thing because we already have the signs figured out. So now what two numbers can I break 24 down into?
12 and 4, or 24 and 1.
24 and 1. Yes, that's right. And then what else? 12 and 2. 6 and 4. 8 and 3. And 6 and 4. Now what about 4 and 6? Except wait a second though, 4 and 6 is just a repeat of 6 and 4. So we don't need to do the repeats. Just as long as you have every combination at least once, that's good enough. Now, which of those combinations can be rearranged and placed together in those boxes so that it'll add up to negative 10? Yep, 12 and 2. So, and by the way, remember I said that you should put the biggest one in the first box? Because watch, that's because the sign in the middle of the first one is the dominant sign, and needs to be bigger so it'll match the sign in the middle of the original problem. So let me go ahead and grab this yardstick so you can see. So since the original one is negative 10, I need to put the 12 with the bigger number with the negative sign. So negative 12 plus a smaller number of positive 2 will add up to negative 10 and match the original. If both signs are the same, if they're like both negatives, then it does not matter. Like the last problem we did a few minutes ago, both signs were the same, so it didn't matter which one we put in which box. But in this case, it does matter. The bigger one needs to come first. So we're done with factoring that one. Does anybody have any questions about that? And you can always double check because negative 12 times positive 2 equals negative 24, like it originally had. And negative 12 plus 2 equals negative 10, like it originally had. So that's the solution. Oh, no, well, that's not the solution, but that's the factors of it. So it is the solution because this problem says you're not supposed to find the solution to the equation. You're only supposed to find the factors of the problem. All right, now, do you feel like you have a pretty concrete idea of that? So let's go to the next level again, and let's see what happens if you have a squared letter at the end of it, as well as the beginning. Ready for that? So let's go to question number 5. So question number 5 says you have x to the 2 minus 9xy plus 14y squared. For some reason, when I was maybe earlier in algebra, these were really hard for me to do because my brain couldn't think about two things at once very well. So what I would recommend that you do is don't even think about the y squared until the end. Just think about the x. So drop the square on the x, break it apart into x times x. Then what do you do with the sign between the x squared and the negative 9xy? Bring that down. Then what do you do next? Make a little rainbow from the negative to the positive. And what sign is the negative times the positive? Negative. So put that negative down in the next one. Then make a big rainbow from the invisible 1 to the 14. By the way, have you learned about how God is invisible? So that's kind of like math because it's like an invisible one. So 1 times 14 is what? 14. 14. And then what factors are there of 14? 1 times 14 and 7 times 2. Which pair could go inside of these empty blank spaces that Taylor Swift made for us that would add up to -9? 7 and 2, right? And then we're done now. So the answer is x minus 7 and x minus 2. Now the order in this case does not matter because you could put x minus 2 and x minus 7 as well, because it would still work because they're both negatives. But I still like to just have a good consistent habits. A lot of times I'll put the biggest one in the first one just to have good habits. Any questions about that? Oh, I forgot one thing. This is not the answer.
It's like, what about the Ys?
Exactly. I said I'd think about it at the end and then I forgot about it at the end. So the y, you do that at the end. So, but you do the same concept though. You just break apart the y into y times y. So put a y there and a y there. And then it will magically work. So just put a y in there next to the numbers. So because -7y times -2y would equal +14y squared. And so that makes it work. Just make sure you don't be like me and don't forget at the end though. Perfect. Any questions about that? So are you ready to try something else out? Let's try something where you have to factor something out before you can even factor something out. So that sounds strange. So number 7 says you have 5x to the 2. By the way, if you were a dentist, you'd say 5x to the tooth power. 5x to the tooth power plus 10x minus 175. There we go. Now notice we talked about in equations, if you're solving equations and there's something in common that you can divide the equation by that's a number. Now this doesn't apply if it's a variable because you can't divide it by a variable to get rid of the variable that you're trying to solve for. That does not work. But if you're trying to get rid of something that's just a number though, if it's a common number in an equation, you can divide both sides of the equation to get rid of that number. But this is not an equation though. So I don't have both sides. So how do you get rid of a number that's in common if you don't have both sides to get rid of it from? Well, instead of dividing both sides by that number, you just factor the number out. So what's the greatest common number that's in 5, 10, and 175? 5. So divide everything out by 5 and take the 5 to the outside. And then you'll be left with 2x in the middle and then negative. Okay, so what's 175 divided by 5? What? 35? I think you're right. Wow, that's crazy. 5 times 3 is 15, so that'd be 150 and plus 25 is, yeah, 175. So the first step you see is to factor the common factor out. That makes the whole problem 5 times smaller and it's going to be easier to do now. What's the second step, do you think? Second step is you keep the 5 out there, but then you break the rest of it down into its own separate problem. So you're going to break it into 2 sets of factors. Or well, not 2 sets, but into 1 set of 2 factors. And of course, you drop the square off the x and you get x times x. Then you keep the sign from the middle of the 2 terms that are next. And then you multiply these 2 terms together, plus times minus. I've got a question though. If you can get a, wait, that's interesting. This is kind of confusing because now it actually looks like both signs come down. Because a positive times a negative is actually a negative. So it looks like we're just bringing the plus sign down and just bringing the minus sign down. It looks like that we're doing that. But remember, we're not really just bringing them both down. We're only bringing the first sign down. And the second sign has to be both signs multiplied together. But it's just a coincidence that it looks like it comes down. What did we do next? We need to make a big rainbow. Now this is an easy mistake to make. You might be tempted to make the big rainbow be too big. Like you might think the rainbow needs to go from here to here. Why would, but that would be wrong. That's why I'm writing in red, because red stands for wrong. Why would that be wrong? Because I already factored that out. So the 5 is no longer part of the factoring problem anymore. I need to draw the rainbow to the first number of what's actually still part of the problem. So I need to draw the big rainbow from the 1 to the 35. And what is 1 times 35 if I ignore the negative? It's just 35 alone. If I break that down, it'd be 1 times 35. That was easy. 2, 3, 4, 5. What are the other factors of it? 5 and 7. Good job. And should the 5 go first or should the 7 go first? Or which numbers? 7 should go first and 5 should go next because positive 7 and negative 5 adds up to 2. Perfect. There's actually a song called Perfect by Ed Sheeran, right? Okay, so there we go. Ah, amazing. We need to have like a little sound effects board that like every time we say a word that like represents a song, the song starts to play. Then number 8. Wow, this is just getting harder and harder and harder. But you're getting smarter and smarter and smarter, so that's the benefit of it. Actually, you've probably seen all of these problems before, but in maybe 5 minutes, we're going to get to one that maybe you haven't seen before. That's the one that I'm excited about. 3x to the third minus 27x squared plus 42x. So once again, there's something in common to this. So you got to look for what's in common. What is in common to this problem? All right, is everybody paying close attention? 3x, yes, 3x. And if I take away the x from the x cubed, it'd be an x to the 2th power like the tooth fairy would like. Then if I divide 3 out of 27, it's 9. Take an x out of x squared, you have 1x left. Take 3 out of 42, you have 14 left. Take the x out, you have nothing left. So this time I have 3x factored out. What do I do next? Now I continue working within the parentheses. So I break the 1 parentheses into 2 sets of parentheses. There we go. And what do we do with the x squared? Break it into what? Is everybody paying close attention? Good job. I bring down the negative sign first, and then what do I do next? Multiply it, and you get another negative. Now, what's crazy is you can always get 2 negatives from a negative and a positive, but you can't get, well, actually, you could get 1 positive from 2 negatives, but you can't get 2 positives, though. So, there's that. What do I do next? Where does the big rainbow have to go? From the 1 there to the 14. And 1 times 14 is 14, right? And then what numbers does 14 break apart into? 14 and 1 and 7 and 2. And it's going to be, which ones are the right ones? 7 and 2, correct. And then we're done with it, right? Perfect. Okay, well, I'm getting kind of frightened now. You ready for number 9? Actually, this isn't the one that's too frightening yet. The one that's next, well, I'm not sure exactly where it is. Let me look ahead. Number 11, that's where it is. Okay, that's the one that's exciting. So number 9 says x to the 4th minus 18x to the 2nd power minus 40. So this is one this is kind of hard to understand though, because the thing is you have to break apart something that's not s squared anymore. How though, and how is it possible, do you think, to break apart x to the 4th into 2 parts? Yes, so you couldn't be tricked. And by the way, just as a hint, a lot of times whatever is in the middle of it, that power of x in the middle of which is x squared, is usually going to be the right one to break apart the first one into. So not always, but usually you can just look at the middle. Since that's an x squared, that's kind of like a hint that x squared times x squared would make x to the 4th. Then what do I do with the sign that's in front of the 18? I bring it down. And then what do I do next between the 2 signs? draw a little rainbow, a baby rainbow, and you get a plus like that. Then what do I do next? I put that plus sign down. You know, it's always kind of frustrating to me that you can get, you can get a double negative from something that doesn't have both negatives, but you can never get a double positive from something that has even at least one negative. But anyway, never mind about that though. We can get one positive though. So negative is a negative times negative is a positive. What do I do next? I draw the big rainbow. Now, so far, we've never really needed to really draw the big rainbow because it's always been a 1. But I'm just teaching you a good habit because one of these days it's going to matter. So 1 times 40 is what? 40. And by the way, is anybody 20 here? So you're already halfway to 40. Isn't that sad?
A year over halfway.
So sorry for, I shouldn't have said such a sad thing.
How old are you?
I'm 41 actually.
Oh.
Yeah, so I'm actually over 40 already, so. But hopefully I'll live to be like 96 like my last 2 grandparents did, or like 95 and 96. So hopefully I'm like less than halfway through life, hopefully. But I could always die like when I'm like really young though. Like sometimes people die of heart attacks when they're like 42. You never know.
You're really manifesting.
No, that's all right. So then what factors make 40? 40 and 1, and what else? 2 and 20, and what else? 4 and 10, what else? Actually, we can stop with that because I already noticed one of them could make an 18. Which pair could make an 18 from? Yep, which order would I have to put them in? 21st and then 2 last, right? So then we're done, right? Because you can't factor, actually, technically, this is partly a lie. Later on in college algebra, we're going to learn that this is not finished because you can still break x squared down apart even more. In fact, I'm just going to teach you this right now. In the next, maybe it's the next chapter, maybe it's even later in this chapter. I think it's the next chapter, but we're going to learn that you can actually take the square root of 20 and just get x times the square root of 20 minus it, and then x plus the square root of 20. Because guess what? 20 times the square root of 20, square root of 20 times the square root of 20 is equal to 20. So you can actually factor anything further all the way down to the bottom level, like all the way down to an x. Except at this point in time, that step right here, we're not ready for this yet though. Although like you really are, but we're not ready for that yet. So the answer that they want in question 9 for this part of the book is just going to be the first answer. That you don't have to factor completely all the way down yet. By the way, then, yeah. So anyway, so that's all. Notice in instructions in number 9, it says factor by doing a substitution, which means factor something else instead of x, like an x squared. But it does not say factor completely. Like all the other questions ahead of it said factor completely, factor completely, factor completely. But it didn't say factor completely on this problem because they only want you to take it this far, but that's not really completely though. But we're not ready yet to factor it completely, but later on we will. Okay, now we're ready for number 10. You ready for number 10? This one's gonna really, I always say this, but maybe I should have less hype. Do you know what hype is? Hype is like when your teacher tells you everything is wonderful. And then tells you what?
What? I said when your teacher tells you all the answers to it.
Oh. Okay, so the next one is x plus 3 to the second plus 19x plus 3 plus 34. So this one is a strange one. This one is just a random one that they just threw at you to see if you could think outside the box. So can any of you, do any of you know why they even invented algebra? Though, I mean, sorry, why did they, the main difference of algebra and arithmetic is they use letters in algebra, right? So why did they want to use letters? To make it harder or easier? Well, supposedly, it might be both, but supposedly they use letters to make things easier. So like if you have a big complex expression, you can just call the whole thing a single letter. to make it smaller so that you can work with it easier. So we could actually call this x plus 3 and that one both, give them another name, and we can pretend like we're like really arrogant and like self-centered. We could call it u to like represent ourselves. It's like u equals x plus 3. Or maybe that represents u, I don't know, but so we're just going to say u equals x plus 3. Now, if we call that thing u, it makes the problem much easier because it's just u to the power of 2 plus 19u plus 34. Look at that. Much easier. So does everybody see how I simplified it by using the letter u? Now we're going to forget about the original problem, except don't let me forget completely, because remind me at the end to go back to the original one. But for right now, though, we're going to forget all about the original problem and just have a new attitude of just this new problem. So what do I break apart the u squared into? U times u, right? By the way, is that red color easy to see? The pink red color? Okay, good. What do I do with the first plus sign? Just bring it down. And what do I do with the both plus signs? Multiply them together. And what do I do with the 1 and the 34? Multiply them together. And then break down the 34 and then use those numbers to get the middle number. So 34 is what? 34 and 1 and 17 and 2. Ah, there it is. So because 2 plus 17 would equal 19. Now in this case, since they're both positives, the order doesn't matter. So do you rather have me say 217 or would you rather have me say 17 and then 2? I think I heard 2 people say 17 and 2. So u plus 17, that sounds cool. Like, isn't that like in Olympics? Don't they have like the U17 Olympics or something? Maybe not. Or maybe it's the U20 Olympics. I don't know. U plus 17 times u plus 2. And wait, that's not the answer. That's the next to the last answer, but that's not the final answer. What do I have to do at this point? Plug in what you really meant. What did you really mean? Yes, you actually meant x plus 3. So I actually have to say x plus 3 in the place of u. And then I have one more step to do. What is 3 plus 17? 20. And then what is 3 plus 2? 5. Yep. Let me do a quick, I won't say anything more. I'll just do a quick check to make sure people are not looking at too many distractions. There was a little bit of a mixed result. Okay, perfect. No, I'll probably forget what I saw, I guess, just this once. By the way, if you already have finished with the whole previous chapter, that's good though. But so x plus 20 times x plus 5 is what? Oh, well, never mind. It doesn't matter what it is because I'm not supposed to solve it, right? I'm just supposed to factor it. So I'm done, right? Now, finally, I've been looking forward to this one forever, but this is the one that I was really actually going to hype you up about, was number 11. Because this is finally the first one that we're going to do, I hope, if I remember right, that doesn't have a 1 at the beginning of the problem. Are you ready for that? In fact, let's skip number 11. Let's do number 13. That'll make more sense. 13 is a better example. So let's do example 13. And it says 6 y to the 2 power plus 17y plus 5. So notice this is a big issue. These are the problems that I used to just really hate. I would literally just this is kind of embarrassing, but I would just like lie in my chair like this and just like put my head on the ground and just like think about them for like 20 minutes until I could think of the answer. Is that a very efficient way to solve them? No, definitely not. It was a waste of time. So is there a more systematic way of doing it? Yes. So first of all, write 2 pairs of parentheses. And you have to have a little bit of faith that it looks wrong, but you'll eventually get the right answer. What you're going to do is this. you're gonna drop the square on the 2 on the power of y, but you're gonna keep the 6. And that looks incorrect. You're gonna keep the 6 in both places. The reason for that is you can't know at the beginning whether to put 3y in the first one and 2y in the second one, or whether to put 2y in the first one, 3y in the second one. Because it's probably gonna be like 3y times 2y equals 6y squared. But you don't know yet which place to go. And the reason for that is you don't know what's gonna get canceled out. So the first step is drop the squared power. Drop the squared power from first term. But otherwise, you keep the first term. So keep the 6, but only drop the squared power from the first term. Then you do the signs. So then you do the signs next. That works the same way. So bring down the first sign as is, and then make the little rainbow to connect the first and the second. And what's a plus times a plus? Plus. So that's also going to be a plus. Then draw the big rainbow. Now, for the first time ever, this is a momentous moment in your life, at least of this day of your life. We're going to get to do the first number, which is not 1, times the last number. And what is 6 times 5? 30. Now we're going to break 30 down into two numbers, 1 and 30, 2 and 15, or 3 and 10, or 5 and 6. And which pair of numbers adds up to make 17? 2 and 15. Yep, correct. Now, does the order matter of 2 and 15? No, because they're both positives. So I'll let you pick. Do you want to do 2 and 15 or 15 and 2? Okay, so since you spoke up so loud and clear, I'll do it your way. 6y plus 2 and 6y plus 15. Now, obviously, you're going to be, the smart ones of you are going to be laughing at me and like, this is the wrong answer, like clearly. Because like 15 times 2 equals 30, not 5. And you're right. What do I need to do to make, I'm going to write this in red because if you don't do it, you'll be dead. No, just kidding. This is urgent, okay? So it must cancel extraneous. That means they're not supposed to be there. Extraneous common numbers. Common numbers slash factors from each pair of parentheses. If there are any. So there's not always any, but there's usually some. So does anybody see a number that's in common to 6y plus 2? Yes, there's a 2 in common. That's the extraneous common factor. Whenever you do this method, it always creates, whenever there's a number at the beginning, it creates extraneous numbers like this at the end, and you have to cancel those in order to make it right. What common factor is there between 6 and 15? 3, right? So you have to, now we're not actually factoring out 3. So do not write a 3 on the outside and like take the 3 out. There's not really even supposed to be a 3 at all. It's just the 3 is only there because there's an extra like extraneous 3 that just got in the problem somehow. We have to get rid of it in order to make it correct. So the correct answer now is, I'll do it in blue because it's correct. The correct answer is, what is 6y divided by 2? 3y. What is 2 divided by 2? 1. What is 6y divided by 3? 2y. What is 15 divided by 3? And now presto, once you do that little tiny extra step, you'll have the right answer, because now 1 times 5 does equal 5, like the original. And if you had multiplied everything else out, it would add up to 17y, and it would multiply to make 6y squared as well. So you just have to have faith to begin it as you're supposed to begin it. Just drop the squared power from the first term, but don't drop anything except for the power from the first term. And then do the signs, and then pick the numbers that add up to the middle number, and then you do that urgent last step, and then you'll have the correct answer at the end. So let's do another one like that. Let's go back to 11 now. Any questions about that? Okay, so let's go to 11. Do you think I can fit this on the same page, or should I go to another page? I can fit it. Okay, so let's do 11. 11 says 7x to the second power plus 12x plus 5. So let's Let's change colors so it's a little easier to see. I should have changed colors already because it kind of runs together now, but. So what's the first step? Drop the squared power from the first term, right? But don't drop the 7 though. Just drop the squared on the x. So put a 7x and a 7x inside the parentheses. Now I'm not going to write the steps again. I'm just going to let you read them back to me. What's the second step after dropping the squared power from the first term? You do the signs. So what's this? What should the first sign be? Plus, and what should the second sign be? What should the second sign be if I multiply those two signs together? Plus, and then what's the next step to do? I forgot to write this, by the way. I should have said double rainbow. I should have written that before. So I do the double rainbow from the first number to the last number, and what do we get from 7 times 5? 35. And what factors does 35 have? 35, 1, I love that one. 7 and 5. That one's good too as well. So which one's the right pair of factors? 7 and 5, correct. Now in this case, only one of them has an extraneous factor, the other one doesn't. We just got lucky that way. So which one has an extraneous common factor that needs to be canceled? Correct. So I'm going to go to red just to remind you it's urgent. So cancel out the 7 from the first one. And once again, some teachers, this is called the Boston method of factoring, by the way. Some teachers may not even know this method because it's really efficient and quick. But they don't know this method. They're gonna, if you divide by 7 like this, they might think that you're trying to factor out the 7 and they might take out points. But remember, we're not factoring out the 7. We're just canceling out the extraneous extra 7. This only happens when you're doing this particular factoring method. But out of all the factoring methods I've seen, this is the quickest. So that's why I'm teaching it to you, because I think it's the best and the quickest. There actually is one other factoring method that's just as quick, but it uses fractions, and I don't think we want to use fractions. So 7x plus 7 divided by 7, you get x plus 1, and then we're done, right? So we're all done with that one. Let's see, what time is it? Let's do one more example like that. Let's do 14, and then we can be done for the day. 14, let's go to black so it's easier to see. 10x squared minus 9x. Uh-oh. Actually, just kidding. By the way, I'll give you a hint. I'm not sure if I'll change the order of the problems and maybe on the final one, but this one actually does not factor. If something does not factor, it's called prime. So forget about that. Let's do 12. 12, sorry, my fault. We only have 2 minutes. Let's see if we can do it in 2 minutes. 2y squared plus 13y minus 45. 2y squared plus 13y minus 45. I'm doing this because this has a positive and a negative sign. So let's drop the square from the y squared, but we'll keep the 2 in front of it. Now we're going to bring down the sign, the first sign the same, multiply the positive times the negative, and you get a negative. Now we're going to do the big rainbow, 2 times 45, which is 90. We don't need the negative anymore because we've already taken the signs out of it. 1 times 90, 2 times 45, 3 times 30. Wow. Or 5 times 18. I think it's 5 times 18. Should the 18 go first or the 5 go first? 18, you're right. Because 18 plus positive 18 and negative 5 would add up to 13. And now which one has an extraneous factor in it? 2 and the 18, correct. And what is the extraneous factor? 2. So divide that 2 to get rid of it. And then you get y plus 9 and then 2y minus 5. And congratulations, if you know how to do that method, you can solve some of the hardest factoring problems super easy. Like if you ever took a placement test for math at Friends University, for example, they have a problem like this on the placement test. Now you know how to do that problem really quick. So good job, everybody. And I'll see you again, Lord willing, on Friday, the 12th. So good job, everybody. And by the way, I won't have an office hour right after this because I'm going to the FCA meeting instead. But I will have office hours from 1 to 3.